Okay, folks, I'm going to do a new series called Watch Me Debug My Students' Code, or maybe eventually I'll get code from like YouTubers and I'll just debug the code. So, what I want to do is basically go through this code and figure out why it's not running. So first, let's run it and see what the error is. And it's going to tell me, oh yeah, I forgot. For some reason, like in Tony, I have to run the code twice before it actually runs. Okay, so it says, let's see. It's running this ODINT derivatives routine, and it's saying that there's a type error. It can't cast dtype to dtype float according to the rule, something about safe. So this is a complicated error because basically what's happening is that it's running this code, but there's some back-end stuff called odpack.py, and it can't run the code. So what we're going to do is basically, I'm just going to throw, I could run this in debug mode. I guess I haven't really. Let's actually run this in debug mode. Let's see what happens. I think the problem with it is the. Is there a step in? Okay, yeah. What's going to happen is when I get to that ODE call, so it's setting all of these things, right? You can see the workspace over on the right. Step over, step over. Come on. Let's get through all this nonsense. Come on. This is why I don't like debug mode. Okay, that should skip all that. Okay, so it's going to make T out, and then let's step in. No, I don't want to do that, because that's just an array. Okay, I want to step in here. Okay, alright, this seems like this is going decent. So can I, like, scroll over? Oh, okay, it's because this is like a subroutine, right? So everything's sort of defined in here. So here's state, right? And then I'm going to click it. And so let's see. So Z is 0. Z dot is 0.17. Is that what he wanted it? Is that what he wanted? Z dot? Z dot 0? Where are the initial conditions? No, Z dot is supposed to be 0, 0. So that's wrong. So let's... How do we stop this? Use stop. Okay. All right, I'm gonna stop. So what's going on here? So he's got. Oh, okay, that's interesting. Yeah, so he's got z dot phi dot theta dot psi and psi dot, right? So the way he's unpacking the states is actually completely different than this. So we need to do one of two things. I think here he's got z dot phi dot. So let's keep it in this order. So z phi theta psi. Wait, z dot phi dot z phi. Yeah, okay, so let's do that. So it's going to be z. Let's see. Then it's going to be. This is all over the place. So z phi theta, and then z phi theta, and then is it psi? Is that what's next? Z phi theta psi. Z phi theta psi. Yeah. So z phi theta psi, okay, and then z dot phi dot theta dot psi dot, okay, and then we just need to fix these numbers. So 1, 2, 3, 4, 5, 6, 7. Okay, so that creates that there. Yeah, so somehow this was unpacked properly, So this is right. All right, so this is why I don't like debug mode, because of the number of times that you have to hit print. Like the code breaks, so I just want to print M. Okay, I'm gonna just hit run. Okay, this is gonna go way faster. Okay, so there's the M matrix. So that looks good. Okay, so let's print the H matrix. So print H. Well, I guess I can just keep print M. That's fine. Okay, so there's the H matrix, a bunch of ones. Let's go ahead and print F. Okay, let's see what's going on there. So there's F. F looks good. It's a vector. We're going to print KD. Okay, see what's going on there. So, oh, okay, this is interesting. So it didn't like this. Local. Oh, okay. I'm sorry. I got a different error. That's KP and that's KD. I thought there was a different kind of error. Okay, so there's KD, KP a bunch of ones, KD a bunch of ones. So we're still okay here. Let's print Q dot and see what's going on there. So that should just be a vector of zeros, right? Z dot, V dot, theta dot, psi dot. That's fine. Let's print Q. So that seems like it's still okay. So Q, so Z phi. So is that, so Z phi, so is phi, does he have it at an angle? Okay, yeah, so he's got phi at an angle, theta at an angle, psi at an angle. Oof. Yeah, okay, so that's a lot of things that are non-zero. Um, let's print Q double dot command, and then let's see, print Q dot command. Let's see what's going on there. Okay, so that's still a vector of zeros. So all of the commands are zeros. Let's print Q command. Okay, let's see what's going on there. So that's Z command is 10, and then phi, theta, psi are all zeros. So if we do this, so okay, so this is probably what's wrong. So KP is a matrix, and if you multiply it by Q minus QC, you actually have to do Matmul. So if we do print gamma like this should be a 4 by 1, and it's not. It's a 4 by 4. So that's a red flag right there. So this should be NP matmul KP comma that, and then NP matmul KD, because it's a 4 by 1. It's a 4 by 4 times a 4 by 1, and so we should get a 4 by 4 by 1. 4 by 4 times a 4 by 1 will give you a 4 by 1. Okay, cool. So there you go. So there's gamma. So gamma is now a 1. A 4 by 1, so that's right. So then let's see what's happening here. So same thing, right? So chi, so the student creates this matrix here. So I'm going to call this like my Gauss matrix, and that's because this is using like some some inversion stuff. So he's inverting the H matrix, multiplying by M. Okay, and so this is where things get kind of weird. So let's do M inverse is NP linalg inverse of M. Okay, and then let's go ahead and print M inverse, make sure that's working. And then what we want to do is we want to do inverse MH. And so let's go ahead and just multiply those matrices together. So that's going to be M inverse H, right? And then let's go ahead and print that matrix, MH. And then, so that's this in here. And then you want to inverse this again. So I guess what we can do is then we can just throw this in here and invert it one more time. And so that's inverse MH. And then let's go ahead and print the Gauss matrix. And then here we're going to have NP matmul of the Gauss matrix, comma, gamma minus F. This is feedback linearization controller. And then we can print chi. So let's see what happens there. Yeah, so I was afraid of this because I noticed that the H matrix was a vector of 1. So I think if you look at the data sheet, like I think, or not the data sheet, there's a derivation for this problem. Like I'm pretty sure this is wrong. So that's a conceptual thing. But let's just look at the code here. So we're printing, I'm losing like where I am here. So let's do gamma equals, and then over here, M inverse equals, let's see where I am. So that's M inverse, so that looks good, right? My mass matrix was, what, 0.05, so 1 divided by 0.05 is like 20, so that makes sense. And then I do M inverse times H, and I get this matrix. I get this matrix here, and you can tell that the entire row is the same, so those are not linearly dependent rows. Actually, every column is the same. Yeah, so this H matrix is wrong here. So there is I'm pretty sure, I don't want to spend time on this YouTube video looking up the derivation, but I want to say the last row is supposed to be -1s, but the top row is supposed to be altitude. So I'm pretty sure that is, so the top row is altitude, right? So that's Z. The second row is phi. So I guess that's supposed to be like the first 2 are negative and the next 2 are positive. And then the next one's theta. So I guess that means the first and third are negative and the second and fourth are positive. And then psi, how does psi work? I think first 2 negative, and then how does it work? It's like 1, 2, 3, 4. So actually, so this should be 1 and 4. So 1 and 4, 2 and 3 should be positive. Okay, and then for theta, for pitch control on the drone, oh yeah, I forgot to say this is modeling a drone. You're going to have 1 and 2 are positive, and then 3 and 4 are negative. And then this one, you want 1 and 3 to be negative, and then 2 and 4 to be positive. Let's see if that... okay, good. I got the same error that I did before. So it looks like, can I print my chi? Or I did already. So let me say chi equals this. Yeah, okay, cool. So I've got chi, which is going to hopefully stabilize my matrix. Okay, so then same thing is happening here, right? So he's doing m inverse times h times chi, but you can only do that in MATLAB. So you want to do, so we already have inverse mh, so that's up here. So we really just need to do qdd dot is np.matmul of inverse m h comma chi, and that'll get the matmuls in there. And then I want to say, let's print qdd dot equals qdd dot. And so we've got qdd dot, so that works. Okay, so then it's probably this state dot command then, right? So let's print state dot and see what's going on there. And let's see, state dot equals. Yeah, so the issue is that if you notice when I printed q dot, it just printed q dot by itself. But when I print state dot, it's printing state dot and then an array, right? And so it's saying that there's an array inside of an array. And it's because of this way that they're concatenating this. So what you really want to do is you want to make the top part an array, and you want to do, I think, h stack. We're going to have to play with this. It's either v stack or h stack. And then we're going to put this in parentheses like this. I think that's it. No, it's not going to like that. It needs one argument. So I think I need an extra set of parentheses around here. And so let's see if... Oh, God. Okay, so that obviously worked. So let's get rid of all of these print statements. So hstack... Wait. Actually, hang on. I'm going to purposely put gibberish so that it throws an error, because I want to make sure that state dot looks right. Okay, and it does. Yeah, so state dot is a 8 by 1. Okay, so I can go ahead and comment out all these print statements. Print. Oh my gosh. I don't know. I just feel like printing is way better than debug mode. I mean, you run it in debug mode, you find an error, and then you have to run it again, and it just takes forever. So badass. Look at that. So that is a drone that goes to 10. There's steady state error, which is odd because the feedback linearization controller is supposed to get rid of that with this MG here, right? You subtract off this. Where's that gamma minus f? Yeah, I mean, you subtract off this gamma minus f here. So that's odd. Is it a sign issue? Maybe this is supposed to be plus. No, that overshot it. I don't want to debug conceptual problems. I mean, at this point, like the code works. So I want to say that's it. I mean, the roll, pitch, and yaw, right, all go to 0, right? This is roll, pitch, and yaw right here. Oh wow, he's plotting like everything. I think the better thing to do would be to plot like, say, z, right? So this would be z. So we could just take a look at z, all right, and then we could plot the first state, which would, or sorry, the first 0th and the first column, which is technically the second column. This would be phi, right? So that's phi going to 0, and then we could do. So I could just loop this. So for x in range, 0 to. I just want to do the first 3 states, and then I'll change this to x, and then I'll do plot, and then I'll just call this state. And then that should give me 4 plots. Oh, I forgot to drop down a new figure every time in the loop. So plt.figure. Okay, so there's z, phi, theta, and psi. So aside from So I would say the code is all there. I guess to recap what was wrong, the first thing was multiplying matrices. You have to use the Matmul function. The second thing was that there was a conceptual issue with this H matrix. So I just put in a bunch of random numbers. So that needs to get fixed. Um, oh, you know why this is overshooting? It's because he's saying here that q double dot is np.matmul inverse of chi. You need to add f to it. That's what happened. You forgot to add the force of mg. Boom, and then it cancels out. So it goes perfectly to 10. No steady state error. So a couple conceptual issues with feedback linearization, and the big thing was the matmul. So I'm going to send this back to my student, and if you like this series of watch me debug students' code, let me know in the comments, and I'll try and make some more, and I'll just screencast every time I get a lot of students' code. I do this a lot. Cool. My kids are crying, so I'm going to go. I'll talk to you all later. Bye.